Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar today. I'm excited about this one, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during our presentation you have a question for our speaker, please don't wait, don't hesitate, just use that question and answer tab on your interface and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so please, we welcome you to submit your questions, comments, suggestions, whatever you want to chat over to us. We will be on the lookout for them, and we might even chat you back. And also, finally, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is From Ticket Time to Real Time, Changing the Status Quo of Operations Work. Our speaker today is Alex Honor, who is the VP of Rundeck at PagerDuty. Alex, thank you so much for joining me today. Really appreciate you being here.
Thank you. Pleasure to be here. Hello, everybody. I'm Alex Honor, co-founder of Rundeck, but now part of PagerDuty. Today, I want to talk about something we've been observing in the industry, specifically how the work inside IT operations has changed and is continuing to change. But first, a little bit about Rundeck. As you may or may not know, Rundeck began as an open source project way back in 2010, so that's about 10 years ago. It later became a commercial software company where we sell Rundeck Enterprise to IT operations teams. And one thing that's interesting about being part of a global open source community is the vantage point it gives you into the world of IT ops and how that's been transforming and how that change has been accelerating over the last year. Today, I'm going to describe a new way of working inside operations that we like to call real-time operations and how it helps business move and adapt faster. Keeping a digital business running has never been an easy job, but especially over the last 18 months. Because changes brought about in 2020, most companies have accelerated their digital transformation initiatives. You know, for those companies that were moving slowly from their brick and mortar days, they've really stepped on the gas. And even for the companies that have been going through a digital transformation, they've accelerated too, transforming more of their lines of business. And our customers are demanding more capacity, more performance, more reliability. While at the same time, businesses are releasing more new services faster than they have ever before. And over this past year, companies are also learning to use new working models, and many have moved from what used to be a traditional everybody in the same building or same campus to that of everybody working remotely. And that has caused people to be more decentralized and have to use more tools and online interactivity to collaborate. And I would say, you know, another thing we're seeing in the last 2-3 months is employees reevaluate their current positions. Some are choosing to leave the company they've been with. Others may be reevaluating the role they've been working in, and maybe you want to try something else. So not only is there a mobility in terms of where people work, but employees are also choosing what they want to do and where they want to do it. Now, as you all know, especially those that have been working in operations like I have been, that it's always been a mix of legacy and new applications. And complexity has risen with the cloud and containers and microservices, even for mid-size SaaS companies. Now, ops is used to dealing with failures, but with the rising scale and complexity, problems and failures can happen much more often today, and they can be a lot harder to figure out. And we'll come back to the picture you see there, we call the Death Star in a little bit, but that just kind of gives you a sense for the scale of complexity. Now, there's been a pressure to open things up, but at the same time, stay in compliance. But how do you stay ahead? How does a company go faster while at the same time try to keep things locked down to avoid risk? So the answer to this question is something we call real-time operations. And today I'm going to make a case for this idea of real-time operations, talk about what gets in the way of it or what has been getting in the way of it, and a few things to focus on in terms of strategy and on how you can achieve some of those benefits. So we'll begin by talking about the business case. And this is kind of old adage, it's hard to disagree with. Everyone believes that speed is a competitive advantage, time to market, to edge out the competition or to leverage a new opportunity is really how we continue growth. But how do we do that faster? And it seems impossible if ops is in a reactive kind of stance, one that you've been, what worked in the past may not let you achieve that speed for what your future needs. So let's first begin by talking about some things to avoid. When you're involved in operations, your life is an unpredictable mix of planned and unplanned work. You'll find yourself frequently getting interrupted. There's always someone who needs you to do something and an endless stream of tickets with your name on it. And often for the same task done over and over again, maybe by the same people. Maybe, it's a weekly thing, a daily thing. Imagine you're a network engineer who's asked by a development team to create or change a firewall rule. That might need to happen every time the dev team wants to release a new version of their application. Now, step back a little bit and imagine that there's more than one dev team trying to release their new versions of their app, and they're all asking the same network engineer to make a similar firewall rule change. And count how many times that could be at the last moment. And now picture yourself as that network engineer, and you've just completed that firewall rule change for one of those dev teams, and you're going back to get your work done. You realize that you might find yourself that you are now the one interrupting others and waiting for them to do something for you. Possibly you're going to work with maybe the security ops team. Maybe you want to review how you're doing those firewall rule changes. Or maybe you're going to work with the platform engineering team because they're choosing some tooling that you might need to use at the same time. So it can often feel like you're on a hamster wheel where you aren't making progress. But if you stop, everything around you will stop and in worst case feel like it's going to fall apart. Now step back and you can picture that there are many work dependencies between key people. And the way they're communicating with each other is oftentimes brokered by tickets. Now, above this is the added pressure from your boss or your boss's boss, and they all want to know why not enough is getting done in the timeframes that they hope to see it done. But at the same time, they realize everybody's extremely busy. It's not for the lack of effort. Everybody's turning their crank and processing those tickets. But when you look at just the overall velocity of how fast the business moves, it doesn't feel like you're making the progress for all the effort that's going into it. We call this status quo ticket time operations, where work is slow and there is a constant friction. It feels like you're thrashing about in a sea of tickets and they all are sitting in a queue waiting for somebody maybe to approve it or to escalate it or to assign it, but they're all sitting in a queue somewhere. Your question might be, if this ticket time operations is so painful, how did it become the norm or the status quo for so many organizations? And why is it still the case? Why has it been like this for so long? You can trace it back to human nature and how we like to organize things. As companies become more successful, they grow in size. And that growth in size leads to a natural reflex for organizing people into teams based on their functional skill sets. It's a highly common management philosophy that likes to put like with like. You might know this as economy of scale. But as any sizable business, nothing lives in isolation. The work has to flow through multiple teams, and someone will always need someone else to do something for them. And we think of that as economy of flow. Now, picture yourself in one of these teams and imagine how you would naturally want to optimize the work that happens inside your team. And thinking a little bit deeper, that would cover things like how you decide what to schedule, what tasks you should schedule for this week, what the priorities are relative to the work your own team needs to get done versus what the business or your customers' priority might be, what process your team should use to get that work done, the tools that your team chooses to implement that process. And then what about the capacity of the team? Are they already busy? Are they swamped? Are certain people in the team busier than others, and others seem to have more time, but maybe for some reason aren't getting that work balanced out to them? And this creates a mismatch and conflicts whenever the work needs to flow between team boundaries. I think priorities are a great example of this. And let's picture that network engineer team again that depends on the security ops team, let's say to review those firewall changes for every app release. So the app team has their priority on this needs to go out the door this week. That raises the priority for the network engineering team, but they are juggling priorities with other competing app teams. And then this all lands on the security ops team because they need to vet out and approve whatever those changes are. And they're juggling maybe other security operations priorities. So priorities are a great example just to visualize how this mismatch between teams can occur because there is a work dependency that flows between all of these teams. To cope with this team alignment, people use ticket queues, as I mentioned earlier, to broker work and to help create communication between these teams of subject matter experts. One side fills out a ticket for what they need. That ticket gets put into a queue, and at some future point, someone pulls that ticket out of the queue, reads the ticket, deciphers what the requester is asking, and starts working on it. Imagine now that your team can only implement that kind of change once a week or maybe every 2 weeks because of a bigger change management cycle or ITSM policy. In an era when the pace of change was slower and slower turnaround times were acceptable, let's say every 2 weeks a deployment or release was okay, the ticket queues did an adequate job, and that's why they became the default way to manage and coordinate operations work in general. But not looking far ahead enough, and now seeing the rise of digital transformation and the pace of change that's come with it, and along the way, the scale and complexity of our systems have skyrocketed. And now, lo and behold, we've discovered something that has already been well researched in other fields, and that's managing work through queues ends up actually being quite expensive. And the same problems they've seen in the other fields, we're now starting to see in the IT field, where you'll see more delays, more variability in how these tasks get accomplished. That will lead to more risk because you have variability and less predictability. Oftentimes leading to more overhead because you need to add extra process or extra approvals. And unfortunately, because people are reading tickets and deciphering and interpreting and going back and forth the requester, can lead to lower quality because you've got to rework the first request to get it right the second time. And I think you can picture working under these conditions can lead to less motivation. So, this has been seen in other fields, and no surprise that working model would cause the same issues in the IT field. But lacking a better way, our industry has been toiling under this slow, disjointed ticket time operations paradigm. And at a personal level, it's taking its toll as our people are getting more and more burned out as they feel frustrated and overworked, while at the same time feel like their actual talents are underutilized. And in these days, you hear a lot about people suffering from burnout. And it's not because people are averse to working hard. Everybody likes to work hard, but when they don't feel like they have control over how the work is getting done, kind of from an end-to-end standpoint, it makes one feel like you're a cog in a machine, but you don't really have the influence or can drive the right way of working to make it simpler, less friction, and get you back to that point of focus where you really feel like you can execute and really want to put the time in. And at a business level, this burden of ticket time operations is just making everything take too long. It's costing too much. The longer it takes, not only does it cost too much in terms of the labor time, but also just the cost of delay and the time to market is costing a lot. And at the same time, it can lead to things breaking as well, breaking too often as you try to push change through when you need to expedite. So here we are today. Demands of IT operations are pushing things to a breaking point, especially in enterprises. It's no longer sustainable to operate under the slow, high friction, and high cost burden of a ticket time operating model. Instead, IT operations demands a shift to what we call real-time operations. Now, what do I mean by real-time? Real-time is the ability to make decisions and take action at the speed of the business. It means instant communication and decision-making. Instead of having the information and control be inside silos, it's distributing control out to the organization and let people work at their own pace and have end-to-end control over the work they need to do. So let's look at where we need to focus to get to this idea of a real-time operations model. What do high-performing organizations focus their efforts on in making real-time operations a reality? I'm going to talk about 4 enablers to letting teams work more independently. And you'll notice that decoupling teams and taking away these work dependencies leads to this ability for teams to work more independently and is really fundamental to this real-time operations idea. But we'll begin with technology. And so the first real-time ops enabler is what we'll call cloud native infrastructure. It's a popular one. You've all done lots of reading about it, so I'm not going to spend a ton of time on it, but I'm going to relate how some of these changes have led to decoupling teams. And I'll begin with container orchestration, since that's sort of a simple one to start with. I remember back when it was first presented on the development side of the house. And in those early days, containers were great because it would let us speed up our dev test cycle. No longer we'd have to wait for heavyweight VMs to be provisioned for us, or how long it takes for them to spin up. Could be 30 minutes to see the results of a build. With containers, we could have that dev test cycle go much quicker, within a single-digit minutes. And it gave developers more control about how to deploy and run their applications in a less coupled architecture. So not only did it let them design their systems so that they'd be inherently less coupled and less dependent on each other, but it also gave a vehicle during release to have something that was self-contained and didn't require the operations side to have to figure out how do you deploy this and how does it connect up with everything else. This gave a nice artifact that would create that clean handoff. So you can see when you step back, containers are a great example of how organizations become higher velocity by decoupling teams. Along with containers, you'll see new developments like service meshes that can reduce the integration burden by using an API-driven infrastructure rather than static configurations inside files on a hard disk someplace. Again, this approach enables a looser coupling between the app and how the configuration is done, but also provides an API service that ops and the dev team can work together on, so that these apps during release could be more dynamic in how that they configure without a lot of verbalized or documented handoffs. So it could be all more automated. Serverless is another example of building a stateless deployment architecture that also lends itself to those same kind of team decoupling benefits. There's a lot of information about cloud native infrastructure, but the key point here is that not only does it promote a looser coupling from a technical standpoint, it also leads to a new way of working between concerns, between the dev concerns and the ops concerns, and can decouple the flow of work. The second real-time ops enabler is monitoring, observability, and AI ops. And we'll start with monitoring. Monitoring has traditionally been the domain of the operations side of the house. And we like to think about it as the ability to watch out for the known unknowns.
I think we may have lost Alex temporarily, hopefully temporarily. Alex, if you can hear us, your screen is frozen and your audio is frozen as well. We'll see if hopefully he comes back. And oh, looks like we just lost him. He'll come back. I know he'll definitely come back. So while we're waiting to see if Alex does come back, I do want to quickly remind the audience that you can submit any questions that you may have for Alex at any time during the presentation, and we will definitely have them waiting for him in the question and answer period. And it looks like he's rejoining us now. Alex, you back with us?
I am, yeah.
All right,
all of a sudden
great.
Yeah, how long have I been gone?
So just long enough for me to remind the audience that they can put in a question if they have one for you at any time. So not long at all. I'm going to let you get back to your presentation now.
Okay, sounds good. Yeah, so just kind of stepping back to where observability fits in. As I mentioned, I like to think about as it's the ability to recognize, or to discover, I should say, the new unknowns that will eventually become the patterns that you would maybe hook up your monitoring to. And observability builds on a few key concepts. Events, that's just that something has happened. Metrics, which is the ability to look at those events and determine, are those things getting better or worse, moving from left to right, whatever the metric is that you're measuring and seeing over time. And then the critical capability of distributed tracing, which is the being able to look within these new distributed infrastructures and understand how these events cross through each component and really learn kind of the dynamics of how these systems work with user traffic. What's interesting is that although monitoring traditionally might have been seen as something that comes from the ops side, we're seeing observability being driven also by the developer teams. And monitoring plus observability helps achieve real-time operations because it creates deeper visibility that helps you learn how the systems work day to day. Then there's AI ops, and there are many definitions out there for AI ops, but when you think about the key role here, you have all this information and signals from all the infrastructure, but how do you aggregate it? How do you reduce the noise? How do you improve correlation and understanding? And how do you spot those patterns? So the AIOps solutions should help you easily manage all your operational events in a single place and automate what previously might have been manual tasks and give responders total situational awareness. There are three enablers we focus on here at PagerDuty for AIOps with respect to real-time operations. First, reduce the operational noise. So help your on-call engineers find the critical incidents and avoid distracting them with storms or fatiguing them with non-actionable noise. And second, identify a root cause. Give responders information they need to quickly triage an incident. And so that can also just mean the ability to run more diagnostics and create more context about that incident. And then finally, automate responses to issues. Let the AIOps find those patterns based on both machine and human data and proactively get ahead with a resolution or predicting issues before they become issues the next time. Again, it's about combining tool capabilities to understand what's happening in real time. This is super important because our systems are only getting more complicated. It's interesting to think about the dev versus the ops mindset when it comes to complexity. From the dev side, the world usually begins by seeming more deterministic. You write code, you build the code, you test the code, it works or it doesn't. It passes the test or it doesn't. Especially when you kind of think about it from the unit development standpoint. From the ops side, the world is more variable, and that's because you've got all the old stuff and the new stuff running side by side. So you see complex behavior. And you also have different software versions. What the pattern was on version 1 might not be the pattern that you see on version 2. And there's possible variability about how the apps are deployed. What kind of infrastructure is it running on? Is it running on a public cloud or private? And you'll be depending on third parties. What load are they under? What issues are they facing? Network traffic, customer workload, a seasonal workload. So all of this adds up and can become a very complex and unpredictable world. Not to mention, on top of all that, you have all these humans interacting with the systems that they need to manage day to day because they need to update it, add to it, modify it. So you go from what might have started off as a deterministic state to a more complex world where you may do the same thing over and over again and get a different result each time. The image that you see here is that one I mentioned earlier, comes from a project called the Death Star, where a university team built out a real-time visualization of microservices. And now I know you can't really read it, but if you just kind of squint your eyes and use your imagination, the gray on the outside are actually the names of the different service instances that are running in production for a mid-sized app. And the blue in the middle, as you can imagine, are all the interconnections where the communication paths are happening between those services. But imagine the scale of a complexity for a service like you might see in Amazon or Netflix, which are those two to the right. Or maybe that's your own application that has that same level of complexity. And it's no surprise that when you see something like that, you come to the conclusion that you can't keep all that in your head. And so when a critical problem does arise, if we don't have that tooling, if you don't have the observability, the AIOps, the ability to interrogate, it becomes almost impossible to spot and diagnose these problems in real time or in the speed that you need so that it doesn't affect your customer experience. The next real-time ops enabler is service ownership. Back in the day when we had less services and a less disconnected organization, the question of ownership was easier. Imagine you had one core service that everybody was working on supporting. There wasn't, microservices and everything already super distributed. Everybody kind of knew who was responsible or who was the expert for what. And it was just simpler when things went wrong, where to ask for help or where things should be uncovered. But with increasing complexity, the notion of service ownership becomes more and more important, because what happens when something goes wrong? What are its dependencies? Who is the person responsible? And who are the needed experts? One example I always like to think about for how companies have coped with this comes from Netflix. You might all know about this, but Chaos Monkeys was famous for testing service reliability. Imagine you had this random process that would go out on the network and randomly just kill a service to prove that it was resilient or not. And if it wasn't resilient, then the service owner would have to, prioritize that and make sure it was resilient. And in the worst case scenario, that could be deprovisioned because it was considered, not resilient or didn't have the clear ownership. Well, they built on that idea with something called the compliance monkey. And that's a similar random process that would go out looking for a service and then check the corporate directory to see if that service had a defined service owner. And if an owner was not found, either maybe doesn't work there or changed groups or was not registered, that service would be deprovisioned. The whole point here is it's just sending a strong message to the organization about service ownership and making this a cultural norm. The other benefit in service ownership as a practice is it helps us build a map. But this is a map about understanding the interaction across the teams of people and the technical systems they're dealing with. So rather than just, does this microservice connect to that microservice, thinking about it from the ownership standpoint, what team depends on what other team? And so you can see this is bringing in the human layer. The last enabler for real-time ops way of working is something we call self-service operations. We're seeing organizations move from a reactive ticket-driven approach we've talked about earlier to one that's more proactive, where self-service is the model and becomes a key real-time ops enabler. But what do I mean by real-time with respect to self-service? It means rather than having the information and control be inside silos, it's distributing that control out to the organization. Part of that is through communicating intelligence, sharing system context, visibility, service ownership, and the right runbooks and decision support. The other part of self-service is about freeing up the subject matter experts. It doesn't do you any good if you have to keep going to the subject matter experts to help to get things done. Turn as much as you can into self-service using runbook automation or event-driven automation based on what the process needs or what's going on in your world. In an incident management scenario, this would mean anyone having the information and the control they need to be able to take action or to have an AI take action on their behalf. So let's take a look at how you enable self-service operations. Today, we're seeing an automation gap in many companies. Businesses are investing heavily in automation, and you can picture tools like maybe config management, Puppet Chef, Ansible, or maybe on the cloud side, Terraform, Helm charts, CloudFormation, and so on. But the automation ends up being fragmented because they live with the subject matter experts. You really unlock the value of the investment in automation when you get other people to use it with self-service. Many times today, you still need the subject matter experts to do things on your behalf because the others don't have access to do it for themselves. Companies are investing in automation, but they aren't seeing the full value because they can't extend it to the people that depend on it to get their work done. They can't enable self-service for multiple reasons. Maybe there's a knowledge gap. They understand the technology or they're not sure how to use it in this context, how to set it up, maybe how to access it or find it. There could be a skills gap. It could be a domain-specific thing or a specialist tool interface. Largely, we see access gap. It's a privileged action, or maybe it relies on a portal interface that just gives too much access in general, and you need to narrow it down. It could be for compliance reasons. Maybe this is a regulated environment, PCI or FedRAMP, or maybe it's along lines of business or types of customers. And you think about it from the incident. If there was an incident, this causes longer incidents because you need to get to those subject matter experts that can call those specialist tools, but that just adds time, largely because of escalation and wait time. But even when it's not things going wrong, just day-to-day kind of work, the turnaround times are long. Like we talked about earlier, having to request across all these subject matter experts through tickets. And it's just, when it's the last minute things leading to interruptions to these subject matter experts that are really busy trying to build new things. You can create self-service through Runbook automation. Runbook automation allows the subject matter experts to define the workflow that spans all the different tools, scripts, APIs, takes into account of permissions and credentials, may simplify how those command line procedures can ultimately be wrapped up and delegated so that process can be driven by the people who need it themselves. And it enables anyone to do anything that previously only those subject matter experts could do, but do it in a way that's secure. It also takes the best practice from your subject matter experts and turns that into the common practice used by everyone. It's really all about connecting anyone to the right automation at the right time. And that means pushing self-service to the people who need something done or who are closest to the problem. And we really think about this as the human layer of automation. What do I mean by the human layer problems? Well, when I think about Runbook automation, it's solving the pains associated with how people interface with their technology and automation, and more than how the automation itself, how the bits and bytes are actually driving the tool or the thing on the network. It's about how do we connect the people and their process to the tools. Now, there's 4 drivers to self-service operations. First, standardization. This goes back to my point earlier of turning the best practice that the subject matter experts use into the common practice that everybody uses. And so that's really kind of unifying the best practice and centralizing it, so it's the common practice. The second would be security. Put guardrails around how the automation should be invoked and how to make sure that people are making the right choices for how they use that automation. And a lot of times it boils down to how do we know we're in compliance or we're within governance on how that automation is being invoked. And so a lot of this can be wrapping your automation within your ITSM, but do it in an automatic way. So anytime the automation runs, it's already connected up to your ITSM process. So those 2 are like pillars to let us get to opening access to the automation. Because we've standardized, we've made the best practice the common practice, and put guardrails, now we're at a point where we can open it up and delegate access to the greater organization, and also integrate. When you picture the network engineer needed to change the firewall rule and the security ops needed to vet it, all because the dev team wanted to push out release, this is where you can start to integrate what were siloed functions into end-to-end flows. And so that's the next level of how you can distribute access, is by creating higher levels of workflow. And then finally, it's all up to date. Instead of writing these down in a wiki or having documents, this all becomes code. And by making it code and by having the code be the thing that actually carries out the process, you're ensuring everything's always current. The code is the implementation and is your document of how the process is implemented. The Runbook automation can be applied to when things go wrong. So whether it's an incident response, in the past you might have gotten an alert and that would then lead to figuring out what to do, maybe escalated a few times. Maybe one was walking through wikis or shared scripts, all of this extending the time it takes to resolve the issue, to a place where your responders have more capability in their hands, have the ability to know what's going on within those alerts, and have the automated actions at their fingertips that normally they'd have to escalate somebody else to do for them. And they can maybe run those diagnostics, or for those known problems, even attempt known working remediations. And that might let the first responder take care of it all by themselves without ever interrupting the subject matter expert. But even for the problems that aren't totally known and have known solutions, the first responder has more tools to diagnose and to get more context, so that if you do have to escalate to the expert has a lot more context, has a bigger picture of where they can focus their time and shorten their response time when that thing goes wrong. But I think just as important as the incident response, maybe more important, is when it's just sort of the day-to-day, the service requests things that building apps and driving services, provisioning, change, maintenance tasks, those kinds of things. Instead of having to wait for the experts to do those things like that dev release needing the network engineer, these things can all be done driven from the release cycle itself. So the Runbook automation enables folks to do the tasks through that self-service way, ultimately letting you integrate into higher and higher level processes. I like to think about where our time is spent, and we see this in the lives of our customers. You know, all the other work that's going on versus the time they're spending on incidents. You can see that while incidents are obviously very critical when things go wrong, from a total time allocation, it's a sliver of what their day-to-day work is. But if you're involved in operations work, you know that there's a lot of other stuff, and that's project work or maybe ad hoc work that's unplanned, but it's not emergency work. So our opportunity to transform how operations work is done spans the entire operations lifecycle. Applying real-time operations focus to these other ops work tasks can make a big difference to improving business velocity. A Runbook automation will also help keep compliance and security happy. In bigger enterprises, you might wonder about objections raised by a compliance or a security team when they hear that you're going to open up access to all of these, which were previously privileged actions, to anyone. But by using the self-service model, you're not giving everyone direct access to those power tools or to those production systems. You're not giving them logins to all of those tools and systems, let's say. Instead, what you're giving them is a vetted solution that's been designed to satisfy the security and compliance. So the compliance team gets an auditable record of who has access to what process. And security and compliance can look at these defined automated workflows and even approve their definition and be part of that design. So the self-service model can distribute control throughout the entire org and let teams move at the speed their business requires. Now, Rundeck by PagerDuty is our Runbook automation solution, and you can connect Rundeck to how you like to work, whether that's integrating Rundeck with ServiceNow. As I mentioned earlier, you can wrap automation with your ITSM, or expose Rundeck directly to an incident. Let's say you get an incident in PagerDuty and you want to automatically fire something from an event rule, or maybe you have your own monitoring tool that you're building a self-healing solution with, or in chat like Slack. where you're already doing a lot of chat ops and that's your preferred interface, or release tools, like I mentioned earlier, maybe for that dev that needs to trigger a bigger end-to-end flow. So users get automation where they need to work and use the interface they prefer. All right, well, let's do a quick recap. The world of operations is rapidly becoming more complex. Speed is a competitive advantage, so we have to move faster. But to move faster, we need to rethink how the work gets done and avoid delays and misalignment from ticket queues. To do that, we move from ticket time to a real-time operations model by focusing on these pillars of cloud-native infrastructure, monitoring, observability, AIOps, this idea of self-service or service ownership, and lastly, the self-service operations model. And by doing all this, we can make security and compliance happier because we're all using a vetted process that they can be part of its design. So that's it for me. Look forward to your questions and speaking further. You can also follow up with me at that contact information you see here. Thank you.
All right, great. Let's dive into some of the questions that we've gotten so far. There is plenty of time. If you do have a question for Alex, please go ahead and use the question and answer tab and get your questions in. You can also put them into chat. We'll move them over for you. We do have one question here from Shakti, who actually points out that with the advent of cloud services, the line between dev and ops is getting blurred. So, for example, developers are now increasingly being expected to know about platforms, infrastructure as code, policies, et cetera. So while there are defined ownerships on one hand, it's blurring the line too. So I guess we're wondering if you have any comments on that.
Yeah, great question. Yeah, especially when you see the service ownership paradigm really be fully embraced. You have that build it, you run it culture. And so there isn't that old handoff between the dev and the ops side. You know, the analogy I like to see, or I like to use, because I think it's a strong parallel, is QA. You know, remember back in the day when QA was a separate team and testing was done outside of dev. Well, with Agile, that concern became part of the doneness criteria and part of the dev cycle. And operations concerns is moving in the same way. You know, failures still happen. So when things used to go wrong, maybe it was in the old days, the ops team having to deal with it. Well, when things go wrong, now the dev team has to deal with it. And so being a dev team, you're going to have an engineering mindset about how you solve that. So how do you orchestrate those actions? How do you also, if you're a dev team and you're signing on call inside your own team, you know, you always have people who are stronger at one kind of problem than another. So how do you make it easier within your own teams to take care of things? So I think the same approach applies. It's just kind of in what department are you implementing that same strategy?
All right, great. Next question here. I agree with you that tickets are not the best way of working. How do we make the cultural shift away from them when they are so ingrained in our current culture and processes?
Yeah, sometimes easier said than done.
Right.
Well, when we work in Rundeck, we always look for what are the nascent standard operating procedures, meaning, hey, these things keep being asked for. They could be, as I mentioned in my talk, every time you do a release, or maybe every time you got a patch cycle or whatnot. Those should be standard operating procedures. And if you're using an ITSM kind of methodology, you know, the bar isn't that high. You just need to exercise it some handful of times through automation. And once you kind of define it as a SOP, you know, you don't have to go through the change cycle, and those become the low-hanging fruit that you want to automate first. So you need a beachhead, you know, you need to introduce this way of working. And I think that's one strategy. There can be other strategies, but, you know, essentially you want to find that low-hanging fruit.
All right, great. Plenty of time, guys. If you have a question for Alex, go ahead and use that question and answer tab. Let's see, here's another one for you. You mentioned that you're focused on solving human layer problems. Can you talk a little bit more about what that means?
Yeah, I feel like we were new with that thinking in the early days of Rundeck. In the early days of Rundeck, automation, of course, was pretty exciting in those DevOps days back in 2010, 2014, in that era. And config management, deployment, those were fun things to work on. Well, that was really about how do you write the DSL? How do you write the desired state? Really the code of how you move the bits around or how you invoke the API. But that was for the engineer that needed to run it themselves. It was like their power tool to make their keyboard time easier to deal with. But when you think about it kind of across the organization, if that subject matter expert's not available, then how do you do it? And how do you build the higher end-to-end processes? That's what we mean by the human layer. The subject matter expert is going to generate a lot of value building new things if they're not interrupted and getting pulled into these toil-like tasks. And that's always been our focus. So this is a gross oversimplification, but putting a graphical interface on top of what was hard is just an example of what we mean by the human to tool interface. And just taking that thinking and broadening it out and bringing it up a level is what we mean by human layer. And human layer is making the hard things easier and plugging into communication and plugging into how work is assigned. It's the people level of how work gets done rather than the kind of the lower level tasks that you're typing on the keyboard to get done.
All right, great. Let's see. Oh, here's a good one for you. This looks like an anti-pattern to swarming. Am I wrong in understanding this?
Probably was thinking of a particular slide, but I'm not sure which slide that might be.
Okay. Well, Shakti, if you want to follow up, please go ahead and do so we understand exactly which one you were talking about. We can revisit it. Okay, so let's see. Here's another one for you. Self-service operations sounds great, but where do I start?
Yeah, I think that's similar to that earlier question about what the low-hanging fruit is. There's different tools that you might already have at hand, like your ticketing system, whether it's Jira, ServiceNow, or something like that. We have some customers that just pull metrics from that, like how often is this kind of request made. That could be one. The other one is called response time hours. So when things go wrong, how many people are involved in it? How much of their time is going in, accumulated across all those people? And businesses are starting to look at that as a metric. So if you start to see problems that occur, maybe chronic issues, and that continually pull in a lot of people, those are great indicators for where you might want to apply this self-service operations model, because you can equip the first responders with more enablement, get them doing things more on behalf of other people, or for those experts that are just getting bogged down by all of these repetitive requests, those would be another set of tasks that I'd look at for, hey, maybe these should be self-service operations. The other thing is, what the interface should be. The interface today is maybe ServiceNow or Jira to ask for that work. Well, without changing how the requester does their job, why not trigger automation through a business rule in those tickets? So instead of the ticket sitting in the queue, the ticket actually fires off an automation that's been deemed a standard operating procedure. That way you don't have to retrain your requester. You give them a better interface, a more stringent form, but now the turnaround time to them might seem instantaneous.
Okay. All right, great. Let's see, I think we have time for one more question here. How do you ensure that things are secure and compliant with self-service?
Yeah, this is a great opportunity where you can work with your SecOps team or your ITSM team about what makes something compliant. And I think one of the easy wins is what used to be a process that an expert would do when requested, and then have to fill out paperwork more or less, put what they typed in the console into the ticket and cut and paste the output of what tool they used into the ticket. And sometimes people forget to do that in a firefight. Just automatically wrap all that. The automation automatically will talk to your ITSM, capture all that for you. So somebody doesn't have to worry about filling out the paperwork themselves. That ensures compliance. From the security standpoint, you get authorization layer. So maybe that's driven from your LDAP or your single sign-on. But you can define rules about who's allowed to do what automation in what environments. That's another place where you can add security, increase your security posture.
All right. Well, we are about 5 minutes to the top of the hour. So unfortunately, that's all the time that we have for question and answer. I believe we got to all the questions, but if we missed yours, I apologize. Please know that the folks at PagerDuty will be getting a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Just another quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following the webinar today, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website as well. So you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, real quick, before we close things out, let's do the drawing for the 4 $25 Amazon gift cards. Our first winner today is Levi M. Congratulations, Levi. Our second winner today is Jim D. Congratulations, Jim. Our third winner today is David P. Congratulations, David. And our fourth and final winner today is Richard B. Congratulations, Richard. We'll be following up with all 4 of you by email to get your $25 Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. Alex, thanks so much for a great presentation. Really do appreciate it. I'm glad you were able to join us after you dropped midway through. But yeah, sometimes you have to pray a little harder to the technology gods for them to listen to you, but I'm glad it all worked out. So thank you again for joining me today.
Thank you.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.